this is Mrs. Fraser, and in this video we are going to be talking about a direct variation. So a direct variation occurs when one variable is directly proportional to another. The dependent variable, and another name for a dependent variable is your y, will always be a multiple of the independent variable, which is your x. The equation can be written as y equals kx, where k is the constant of variation, or this is what you're multiplying by, so it's your multiple. So let's look at an example of a direct variation. Y equals 3x is a direct variation because it is only multiplying my independent variable of x to get my dependent variable of y. So we're going to create a table of values in a graph. So I'm going to take -2, my x value, and multiply by 3, -6. -1 times 3 is -3, and I'm going to continue that down my table. So 0 times 3, 0, 1 times 3, 3. This is a 0. And 2 times 3 is 6. And then I'm going to graph this on my graph. So I have -2 and -6, -1, -3, 0, 0, 1 and 3, and 2 and 6. So what we should see here is that we have a straight or a linear graph. We have a linear graph that passes through the origin, just like a proportional relationship. So a direct variation is also known as a proportional relationship. Okay, so let's go over our key features of a direct variation. So a graph, just like a proportional relationship, passes through the origin. Okay, some other things, descriptions that we have is it is only multiplying. So a multiplying relationship. And my equation looks like y equals kx. So let's look at numbers 1, 2, and 3 and identify our direct variation. So which graph represents a direct variation? Well, it needs to be linear and pass through the origin. So that would be my first graph. Which equation represents a direct variation? Well, it should only be multiplying my independent variable to get my dependent, so y equals 10x. And then we know it should be multiplying by a constant of variation, the same number each time. So if I look at the two tables, my first table appears to be multiplying by -3. But if I continue downward to 1, this would be 1 times 3. So this would not be a direct variation. But my next table is multiplying by 2. And if I check all the way down, I can see that is multiplying by 2 all the way down. So my second table represents our direct variation. So now let's look at how we can use a direct variation to solve problems. John makes $12 per hour delivering newspapers. Write an equation representing this proportional relationship. So they've told me it's a proportional relationship, meaning I know that it's going to be a multiplying relationship, but I can also build a table to help me understand the relationship a little better. So my x would be my hours, my independent variable, and my dependent variable would be the cost or the money, and that would be my y. So at 0 hours, John is going to make $0. And at 1 hour, John is going to make $12. And at 2 hours, he'll make $24. And at 3 hours, he'll make $36. So hopefully you're seeing that we are multiplying my hours by 12 or my x by 12. So to write this as an equation, I should have y equals 12x. Okay, looking at number 5. The value of y is directly proportional to the value of x. If y equals 180 when x equals 36, what is the value of y when x equals 29? So I'm going to build a table to help us understand the relationship. So there's lots of ways to approach this, but x is 36 and y is 180. Since we've already talked about that we have a multiplying relationship, one thing that we can do is we can actually find how much it would be for one x value. So if 36 is 180, I'm going to go ahead and divide 36 by 36 to get 1. That means I'm going to also divide and do 180 divided by 36. And this is going to give me my unit rate of 5. So if x is 1 and y is 5, what is y when x is 29? Well, now I know, since I know how much it is for 1, I can go ahead and multiply times 29. So I'm going to do 5 times 29. So my answer is 145. Okay, let's look at a different example. The value of y varies directly with x if x equals 144 when y equals 16. What is the value of x when y equals 24? So again, I'm going to build a table, x, y. So if x is 144 and y is 16, once again, I can find my unit rate. So I'm going to do 16 divided by 144. And that's going to give me 1/9. So I would definitely want to use my calculator for that. And I'm looking for my value when y is 24. Okay, so I know that if my unit rate is 1/9, that I'm multiplying by 1/9. So this is a particularly difficult one for me. I know that my unit weight is 1/9, but it makes it kind of difficult for me to figure that out. But if I know this is a direct variation, I also can use some other information to help me. So if it varies directly, that means that I can actually find how much y, like how much it is for y. So that might help me a little bit as well. So if I'm dividing 16, for instance, I can divide it by 16. Okay. And I can get 1. That means I'm going to divide 144 by 16. So I'm kind of taking a roundabout way because I'm having a hard time figuring out what to do with my 1/9. And if it varies directly, that means that I can do this because it's a proportional relationship. So I'm going to do 144 divided by 16. And I'm going to get 9. Okay? So now what I have is a really easy relationship. 1 times what will get me to 24? Well, hopefully you're saying 1 times 24. So now I'm going to do 9 times 24 because it directly varies, so it should be the same relationship. And now that I've done that, I've gotten there a lot easier than I would have the other way. So I get 216. Okay, number 7. The number of words that Jan can text varies directly with the time spent texting. If she texts 45 words in 5 minutes, how many words can she text in 11 minutes? Okay, this one seems a little easier than the last one. So we have our x and y value. In 5 minutes, Jan can type 45 words. So in 1 minute, how much can she type? Well, I know that 5 divided by 5 is 1. So I can take 45 and divide it by 5 and get 9. So now I have my unit rate. So now I need how much she can type in 11 minutes. So I'm going to multiply by 11. So 9 times 11 is 99. That means she can type 99 words in 11 minutes. Okay, so hopefully we've learned from a direct variation that you have a multiplying relationship that varies directly with x and y. So whatever I can multiply to get from x to y, but I also can multiply or divide to get from x to x or from y to y. And those relationships will always be equal to each other in a direct variation.